Good morning, good afternoon, guys. I hope you're all having a good day so far. Today we're going to be looking at assignment number 12, objective 3. We're still looking at quadratic functions and their graphs, but we're going to be looking at the third objective. We will describe graphs of quadratic functions of the form f of x equals x plus h squared plus k. I made the same mistake in these where you got to cross out this squared and put it on the outside of the parentheses. I'm so sorry that I did that, guys. The essential question we should be asking ourselves as we move forward is what kind of transformation, now we know what a transformation is, will we see for the function? We will describe graphs of the form x of x plus h squared plus k. And you all will sketch graphs of quadratic functions and label the vertex and axis of symmetry. Let's take a look at some transformations. Remember, we learned this in objective 1. It was assignment number 11. So I'm going to put, this is from assignment number 11. Go back and look at your notes. X squared plus k. So with our just x squared, we know this is the graph of x squared. It should be like in our brains now. And when you add a number here, whatever number you add will shift. The transformation is that you're going to move upward or downward. So if k is positive, you shift. This is the vertex. Zero, zero. If it's positive, you're going to shift up k spaces. And if it's negative, you're going to shift down k spaces. Okay, if it's positive, you shift up k spaces. And then what we learned in assignment number 12, objective 2, was that when you have x plus h squared, that transformation shifts your graph left to right. Now this one was kind of like the opposite. If h equals negative, you shift to the right. But if h equals a positive, then you shift to the left h spaces. Okay. And when you have this case, when you have something that looks like where you have both f of x equals parentheses x minus or plus h squared plus k plus some number, what's going to happen is this and this are going to define your h and your y in the coordinate point of the vertex. So the vertex is whatever number h is and whatever number k is. And this is actually going to be the negative of h. Okay, and the axis of symmetry is also x equals negative h. So we'll see what that looks like here in some examples. I'm going to pause there so you can write this stuff down in your notebook. In your worksheet. Let's go up to, what do you think, we're right here. What do you think will happen when we combine two transformations in one function? So what do we say? This makes you go left or right. And adding a number here outside of the parentheses either makes you go up or down. Okay, so up or down, left or right. So it's pretty simple. We're going to have two transformations here. Our x squared, so remember, this is our base, this is our reference. X squared, which is always at these points, we have the vertex. What the heck? Vertex at 0, 0. So what's going to happen is you're going to have two transformations. Remember, if h is negative, you shift to the left. To the right. So you're going to shift 2 units right. 1, 2. But you also have this 5 out here. And we know that that number makes you go 5 units upward. So in addition to moving from here left to places, we're going to go up 5. 1, 2, 3, 4, 5. Okay. And that's it. So every point on this parabola shifted to the right 2 units and up 5 units. And that's it. Okay. Oh, vertex. Our new vertex, remember we defined the vertex to be h comma k. Whatever the value of h is, whatever the value of k is. But we need to do the opposite of h. So the opposite of h is 2. And then k is 5. And let's see if that matches up. 2 and 5. So our new vertex is right here. 2 comma 5. And I didn't define this in the last one, but the axis of symmetry is this invisible line that cuts this parabola right in half. And it always runs through the vertex. And all you have to do is draw it. And the way we write it is we say that x is equal to 2. Because this line passes right through to it at x. Okay. So I want you guys to solve, use these concepts, shifting left or right. Remember, left, right is opposite. So if the sign is negative, you go to the right. If it's negative, if it's negative, you go to the right. Positive, you go to the left. And if this number is positive, you go up. And if it's negative, you go down from 0, 0. Okay, remember, our reference is always 0, 0 for the x-axis. Okay, and that's it. Good luck with these practice problems. Try to work on these two on your own and figure out if you can identify why the vertex is 3, -4, and -2, 3. Okay, good luck.